Explain your answers to the following questions regarding double slit interference. Given a double slit experiment with d as the spacing between the slits, lambda as the wavelength of light, and L as the distance between the slits and the screen. If you want the spacing between the constructive interference fringes to get bigger, should you increase, decrease, or keep L constant?
For number one, you should increase L because as you increase L by using this equation, Y will increase.
Which wavelength of light will have its first maximum be located further from the central maximum? Red light, the longer wavelength, or blue light, the shorter wavelength?
It will be red light because it has a longer wavelength.
If you want to increase the distance between the central maximum and the first maximum, should you increase, decrease, or keep D constant?
You should decrease D, so then if you decrease D, it will increase Y.
If the double slit experiment uses D equals 4 micrometers, L equals 1.5 meters, and lambda equals 400 nanometers, what is the distance on the screen Y between the central maximum and the third minimum? This is the third location above the central maximum that experiences destructive interference. Do not use small angle approximation. So we know that we can find delta capital Phi because you're going from the central max to the third minimum. So you have 1 pi, 2 pi, 3 pi to get the third max. 1 pi, 5 pi, 1 pi, 3 pi, 5 pi to get the third maximum. You know that they're in phase, third minimum. You know that they're in phase, so for delta initially, so for delta little phi, you're going to have 0. We're given the wavelength, and we're given our distance d between the slits, and we can solve for delta r using this equation. Capital delta phi equals 2 pi delta r over wavelength plus delta little phi, and so we have 5 pi equals 2 pi delta r over 400 times 10 to the negative 9th meters, and we solved that and got delta r equals 1 times 10 to the 6th meters. And then we plug that back in as delta r, and we're able to solve for sine theta, and theta is 14.5 degrees. And then from there, we know that y equals L tan theta, so we plugged in 1.5 and 14.5, which we solved here, to get y equals 0.3879 meters.